Hi, my name is Punnatorn On-Kam from class 4A, number 24. Today I'm going to give you a brief explanation of linear motion. Linear motion is basically motion in a straight line. First, we need to understand the difference between distance and displacement. Distance is total distance traveled, have no direction, which is scalar. Displacement is the distance traveled. It have a specific direction, so it's a vector quantity. For example, if you want to get from point A to C, and you go from A, B to C, it will be 800 meter, which is a distance travel. But displacement is you count it from directly A to C, which is going to be 400 meter. Next, speed is the rate of change of distance. You can find it with d over t. It's a scalar because it uses distance, not displacement like velocity. Velocity is rate of change of displacement. Use s over t. It's a scalar. It's a vector because it has direction. Next, acceleration is the rate of change in velocity. You can find acceleration with delta v over t is equal to final velocity minus initial velocity over time. If final velocity is smaller than initial velocity, that means there's acceleration. If final velocity is less than initial velocity, that means there's deceleration. Okay, so next is the four main equation for linear motion. In this, I'm going to use s as distance, which is the distance traveled in total, u, which is the initial velocity, v is the final velocity, and a is acceleration. T is going to be time. Okay, the first one, v equal to u plus at. So we mainly use this one when the distance is not given because there's no distance needed for this equation. Next, distance is equal to 1 over 2 in u plus v multiplied by t. 3, s equal to ut plus 1/2 at squared. We use this one when the final velocity is not given because there's no final velocity here. And this one we use it when, for the second one we use it when there's no acceleration given. 4, v squared equal to u squared plus 2as. We use this one when the time is not given. As you can see, there's no time given there's no time needed for this equation. So these four equations have different uses for what you are given and what you want to find. So that's gonna be it for linear motion. Thank you.
Okay, my name is First. I am responsible for doing topic torque and equilibrium in this group. So in nomenclature of equilibrium, if an acceleration is equal to 0, the force is equal to 0. But in this case of a torque case, you can put something like S equal to mass times gravity. It's especially that early a torque can use this, I guess. So torque is a moment of force. So a formula for finding torque is torque equal equal force times the position from a center of mass to the end of it. So it's something like a draw. So let's imagine that this is a draw. This is the center of mass. So we we push the dog this way back. I apply the force here, so I push it back. So, so in example that, let's imagine that I apply 50 force to the dog equal 50 times. So and then let's imagine that this dog is a 5 meter long. So root 5 times this together, so we get 250 Newton. Okay. So and there is a talk that will try to do something like a phutawan. There is a counterclockwise top and a clockwise top. So the counterclockwise top we put it as a positive top, and a clockwise top is a negative top. It's kind of weird that they put a counterclockwise as a positive and clockwise as a negative, but let's go with it. So next I will give you an example of an equilibrium of a top that use this seesaw formula. So next. Okay, so now I will give an example about a top. A top in place of a seesaw, the seesaw one. Let's imagine that it's a seesaw that you play when you were a kid. So there is a heavy kid here. He weighs 70 kilograms. So where will the person that is smaller, the smaller kid, let's imagine that he is 20 kilograms, will be in this one. So this distance between here, I will explain it to be a 2 meters. So where will the smaller kid, the lighter kid, need to be to equal this heavy kid 700 Newton. So in order to find the equilibrium is that you the top, so FR equal FR. So in this top case that you can use F is equal mg instead of ma. So you can use this instead. So this kid weigh to 20 kilograms. So he will turn into about 200 Newton. So and this kid will turn into about 700 Newton. So we put this here. So 200 Newton equal to 700 Newton times to the distance between the center of mass of the seesaw and the kid. So now we find the equation. If I did this right, this is would be 1,400 divided by 200. So we cut it. So the distance that the smaller kid need to be far away from the center of mass of this point is actually 7 meters long. 3 times longer than this one. So I hope you can understand what I am saying, because I think I don't even know what I am saying. So thank you very much. So next one.
Hello, today I'm gonna
present you about dynamic. Dynamics deals with causes of motion, so it's related to forces. 1. Forces defined as a push or pull. 2. Forces can change state, shape, and position. For example, like we kicking the ball. 3. Causes of motion on an object is always a force. And remember, force is vector quantity because it has also magnitude and direction. And the unit of force is Newton. So moving on to the next is resultant force, or we just call net force. If net force is in the same direction, we need to combine F1 and F2 together to get the resultant force. For example, we get 5 Newton to the right and 6 Newton on the right too. So we need to combine them 5 plus 6, so it's equal 11 Newton. So you look at which direction it's go. It's go to the right, so it's 11 Newton to the right. So the second is opposite direction. If F1 act on the right and F2 act on the left, we need to minus that. For example, like 10 Newton to the right, 5 Newton to the left. We need to minus. So 10 Newton minus 5 Newton is 5. So we get resultant 5. And you look again, which has greater force. So 10 has greater force than 5. So it's 5 Newton to the right. And the last one is perpendicular. Okay, so example, 5 Newton to above and 3 Newton to the right. And we need to find resultant from here, and which has angle too. So we need to do like this. So resultant force equal root F1 square plus F2 square. So my example is 5 square plus 3 square. So we get 25 plus 9. So is root 34. So it's basically of dynamic. So next is resolution of force. Resolutions of force is about finding Fy component and Fx component. And Fy is in vertical and Fx which is in horizontal. So example, when 80 force act on object, find the horizontal component and vertical component. So Fx is horizontal. So if you want to find, you need to get force And fx, we need to use cos theta. So we get 80 multiply 4 over 5. Then we get 64 Newton. So 64 Newton is act on horizontal. And Fy, we use F sine theta. So F is 80 multiply 3 over 5. So we get 48 Newton. So on horizontal we get 64 Newton and vertical we get 48 Newton. So pretty much it. Next is normal force. Normal force is a force that exerts on an object. Normal force is perpendicular to the surface. So the picture will be like this. Perpendicular to the surface. Fn, straight ball. Which is weight. So normal force equal to mg. I'll give some example. If an 3 kg box, kilogram box is rest on horizontal surface, what is the normal force acting on the box? So we got some block that 3 kilogram, and we want to find normal force. So we got mass 3 multiply g, which is 10. So we get 30 Newton. So normal force is 30 Newton. Next, force of friction. So friction force is the force that opposes the motion of the body. Friction force results from an interaction of surface. So friction is always opposite to the direction of the motion and tends to decrease net force. So delta F is friction and F is force. So whenever we act a force, there is friction that's against our force. So the equations of frictions is friction equal million. It's mil and normal force. So mil is of friction. And N is normal force. And friction has two types. First one is static friction. And two is kinetic friction. So the equations is if static friction equal mu n, and kinetic friction is kinetic friction equal to mu n2. So it's exactly the same as this. Mu is coefficients of friction and n is normal force. So for the final one, inclined plane. So picture looks like this. It has frictions to this and mg sine theta to down and mg from the object and mg cos theta a little bend from the mg, and normal force act on substrate. So n is normal force, F is friction. So if we want to find the friction force from the inclined plane, we need to use friction formula. Is mu n, but we need to use mg cos theta too. So it would be mu mg cos theta. So okay, I forget to give it a mil. So the mil is 0.2. So we get 0.2 by 40 and cos 37. So for cos 37 is 4/5. So overall, we get 64 meters. Then, if you want to find applied force on inclined plane, we need to use mg sine theta minus force that we act from here equals 0 to find applied force. So mg is 60 sine 30. So sine 30 is 1/2 0. So F equal 30 Newton. So that is pretty much about dynamic. Thank you.
Hello, my name is Akarawat udomlaksananont from 4A, number 22. I'm going to present the work, energy, and power. Work done by W on an object is defined as a product of force F acting on the object and distance traveled S by the object in the direction of force. So work it have three formula. The first one is W equal Fs number 2, W is equal Fs cos theta. Number 3, W friction equal F mu normal force distance. The next one, energy, it have three solutions to. The first one is kinetic energy, 1/2 mv square. The second one is potential energy, mgh. The third one, elastic potential energy, 1/2 kx square. Law of conservation of energy is initial energy equal final energy. The last one, power, is the rate at which work is performed by force. P equal W over 3 over T. So the unit of power is joule or watt. Thank you.